Module 3. Biometric. In the fascinating realm of forensic science, biometrics plays a starring role. Picture biometrics as the Hollywood of identification techniques, a galaxy of stars, each with its own unique sparkle. These stars include facial recognition, a kind of celebrity spot-the-face game, iris scanning, akin to peering into the soul through the eye, voice recognition, the audio equivalent of name that tune, and fingerprint analysis, the classic whodunit lead actor. Now, let's delve into the world of fingerprints, an art form so intricate that it could be the brainchild of nature's own Leonardo da Vinci. The principles of fingerprints are like the three musketeers of forensic science, inseparable and formidable. First up is the principle of uniqueness, which states that no two people share the same fingerprint, not even identical twins or doppelgangers. Next, we have the principle of permanence, ensuring that fingerprints are the ultimate lifetime commitment. They remain unchanged from cradle to grave. Lastly, the principle of variability guarantees that each fingerprint is a snowflake with intricate patterns that make it distinctively unique. Imagine a library of fingerprints, with each print a book telling its own story. This is where the Henry classification system, a librarian of sorts, steps in. Developed by Edward Henry, it sorts these unique stories into categories based on patterns like loops, whorls, and arches, making it easier to find the book you need in this vast library. Our next stop is the Automated Fingerprint Identification System, AFIS, a high-tech detective with a magnifying glass. Think of it as a digital Sherlock Holmes, sifting through millions of prints at lightning speed to find that one clue that solves the mystery. Fingerprints, however, love playing hide-and-seek. They come in three disguises: visible, the attention seekers, boldly showing themselves; plastic, the soft and moldable ones, leaving their mark in substances like wax; and latent, the secret agents, invisible to the naked eye. Unveiling these latent prints requires a bit of magic, from the classic dusting technique that's like sprinkling fairy dust, to the high-tech electrostatic and gel lifting, which is akin to using a wizard's wand to make the invisible. But once you've caught these elusive prints, you must preserve them like a precious artifact. This involves carefully photographing them, treating them with reverence and precision, ensuring they remain pristine and untampered, ready to tell their tale in the court. Finally, let's talk about the FBI's next-generation identification system, the superhero of biometric systems. It's like the Avengers HQ of identification, housing not just fingerprints, but also palm prints, iris scans, and facial recognition. This system is a testament to how far we've come in the quest to uncover the truth, to ensure that no secret remains hidden and no story untold. Firearms and ballistics forensics. Forensic science continually unveils the hidden narratives behind criminal activities, often relying on the silent yet eloquent testimony of inanimate objects. Among these, firearms and related evidence hold a pivotal role in crime scene investigations. Let's embark on an exploratory journey into this intriguing world, understanding the intricate details that help forensic experts weave together pieces of a violent puzzle. The interaction between a firearm and its ammunition is a dance of precise mechanics and physics. When a gun is fired, it leaves unique marks on the bullet and the cartridge case. These marks are akin to the distinct brushstrokes of an artist on canvas, providing crucial clues about the firearm used. Class characteristics. Think of these as the general features of the firearm, like the make and model of a car. They include the caliber of the bullet, the number of lands and grooves in the barrel, and their direction of twist. These characteristics can narrow down the type of firearm used, but are not unique to a single weapon. Individual characteristics. These are the unique, microscopic marks left on bullets and cartridge cases due to minute imperfections in the barrel's rifling, the firing pin, the breech block, and other components of the firearm. For instance, when a cartridge is fired, it recoils and hits the breech block, leaving distinctive marks. These individual characteristics can potentially match a bullet or a casing to a specific firearm, and of databases. In the quest to match firearms with bullets and casings, the FBI and ATF have developed sophisticated databases. These digital repositories are like vast libraries containing detailed records of ballistic evidence from previous cases and test fires. By comparing new evidence with these databases, investigators can link a specific firearm to multiple crime scenes or determine if it has a criminal history. Forensic experts use a blend of science and detective work to answer two critical questions. How far was the weapon fired from the target, and did a particular individual fire the gun? Distance determination involves examining the gunshot residue and patterns on the target. Close shots leave distinct residue patterns, while further distances might only leave subtle traces. As for identifying the shooter, tests for gunshot residue on a suspect's hands can indicate recent handling or firing of a weapon. However, it's more of a clue than conclusive evidence, as residue can be transferred or washed off. The mystery of vanishing serial numbers. Serial numbers on firearms are like their unique fingerprints. However, criminals often try to obliterate these numbers to hide the weapon's identity. Forensic scientists play the role of history detectives here, using chemical and physical techniques to restore these numbers. This process often feels like coaxing secrets out of metal, revealing tales of the weapon's past. The collection and preservation of firearm evidence are akin to handling rare artifacts. Every piece of evidence, be it a bullet, casing, or the firearm itself, is treated with utmost care. This ensures that the intricate marks and residues are preserved for detailed examination and comparison. In forensic science, everything leaves a trace. This principle extends to tool marks, footwear, and tire impressions. These impressions, whether left on a soft surface like soil or a hard one like metal, carry both class and individual characteristics. Class characteristics might tell us the type of shoe or tire, while individual characteristics can lead us to the specific object. When collecting these impressions, photography stands out as the best documentation method, capturing the fine details in their unaltered state. Sometimes, oblique lighting is used to enhance the visibility of these marks, especially in tool mark investigations. Bloodstain pattern analysis basics. Imagine a crime scene as a canvas, where each bloodstain is a brushstroke revealing key elements of a tragic tale. The texture of the surface on which blood lands tells a story of its own. Smooth surfaces like glass result in less distortion, akin to a clear reflection in a calm lake, whereas rough textures such as concrete create erratic and complex patterns, much like the disturbed ripples in a turbulent sea. Directionality and angle of impact are the compass and protractor of bloodstain pattern analysis. The shape of a bloodstain, especially the pointed end of an elliptical stain, indicates the direction from which the blood originated. It's like following the breadcrumbs in a grim fairy tale, leading investigators to the source. The angle of impact, determined by the degree of circularity of the bloodstain, is the forensic equivalent of angle measurement in geometry class, providing clues to the position of the victim or perpetrator at the time of the incident. Impact spatter patterns are like the genres of a bloodstain library. Each type, low, medium, or high velocity, tells a different story. Low velocity spatters are the gentle drops, medium velocity resembles the splatters from a violent sneeze, and high velocity is the fine mist typically seen in gunshot wounds. Understanding these is like choosing the right book to understand the story of the crime. The area of convergence and the location of origin are the X marks the spot in our bloodstain story. Determining the area of convergence, the point on a two-dimensional plane where the bloodstains seemingly originate, is like tracing back the flight paths of several airplanes to a common airport. The location of origin takes this a step further, adding a third dimension, turning our 2D map into a 3D model, and pinpointing where the bloodshed began. Various blood pattern types are akin to different brushstrokes used in painting. Each pattern, from cast-off to arterial spurting, from expirated blood patterns to voids, tells a part of the story. Cast-off patterns are like the flicks of a painter's brush, arterial spurting, the dramatic splashes of a passionate artist, and voids are the negative space, the untold part of the story. Each of these patterns holds clues to reconstruct the events at a crime scene. They are the forensic storyteller's best friends, helping piece together the chaotic puzzle of a violent incident. The documentation of bloodstain patterns at a crime scene is akin to meticulously cataloging every book in a library. Photographs, sketches, and notes form the trilogy of this documentation process. Photographs capture the scene in its raw truth. Sketches map out the spatial relationship between bloodstains, and notes are the annotations in the margins, providing context and details that pictures and drawings cannot. In this process, it's crucial to be both an artist and a scientist. An artist to appreciate the chaotic beauty and tell the story hidden within, and a scientist to methodically document and analyze each detail. Drug dependence and analysis. Imagine a seesaw in a playground. On one side, there's psychological dependence, akin to an intense craving for the emotional high a drug provides. This is the realm of the mind, where the need for a substance becomes a mental quest. On the opposite side, physical dependence sits heavily, characterized by the body's acclimation to the drug. Discontinuation here leads to withdrawal symptoms, a clear physical manifestation of dependence. Both forms are like dancers in a complex tango, often intertwined in the world of drug abuse. Classifying commonly abused drugs. In this unenviable lineup, we find narcotics, depressants, stimulants, hallucinogens, and cannabis. Narcotics, like morphine and heroin, are notorious for their pain-relieving and depressant effects. Depressants, think alcohol and barbiturates, slow down bodily functions. Stimulants, such as cocaine and amphetamines, do the opposite by kicking the body into overdrive. Hallucinogens, LSD for example, lead the user on a psychedelic journey, while cannabis, well known as marijuana, has its unique set of effects. Collection and preservation. Gathering and preserving drug evidence is akin to curating artifacts for a museum. It's a meticulous process where integrity and purity of evidence are paramount. This involves careful collection, avoiding contamination, proper labeling, and ensuring a secure chain of custody. It's like handling a fragile relic that holds the key to unlocking mysteries. In the laboratory, routine drug identification is a symphony of techniques. Chemical color tests provide quick clues, while microcrystalline tests reveal unique crystal structures of specific drugs. The Marquis test, for instance, turns purple in the presence of heroin. It's a chemical ballet where each move is precise and each reaction tells a story. Chromatography. Chromatography, in its essence, is like organizing a parade where components of a mixture are separated based on their pace. Different substances move at different speeds, eventually spreading out into identifiable bands. It's a race where each participant reveals their true identity at the finish line. Thin-layer chromatography is the minimalist artist of the chromatography world, using a flat, stationary phase and simplicity to its advantage. Gas chromatography, on the other hand, is like a high-speed train where a sample is vaporized and carried by an inert gas through a coated column. TLC is about simplicity and subtlety, while GC is all about efficiency and speed. Ultraviolet and infrared spectroscopy are like detectives that use light to unveil secrets. Ultraviolet spectroscopy looks at how substances absorb UV light, revealing intricate details about their structure. Infrared spectroscopy, meanwhile, examines how molecules vibrate under IR light, each producing a unique fingerprint. It's a dance of molecules with light, each step providing critical insights. Spectrophotometry, in its elegance, measures how much a chemical substance absorbs light. By examining this absorption across different types of electromagnetic radiation, it tells us about the substance's purity, concentration, and chemical properties. It's like listening to the subtle notes in a symphony, each note revealing something about the composer. Mass spectrometry is the Sherlock Holmes of analytical techniques. It identifies compounds by breaking them into ions and measuring their mass-to-charge ratios. This method is incredibly precise, able to deduce molecular structures and atomic compositions. It's a detective story where every fragment is a clue. Remember, the collection and preservation of drug evidence are as crucial as the analysis. It's the beginning of the story, where every detail matters and every step can alter the narrative.